that there are many variations or varieties on the earth which we have seen: oceans, continents, mountains, plateaus, and plains on the continents. And somewhere we see the rainfall is low and high. Okay, and here in this chapter we are going to study one particular important form of diversity that we cannot see but we can feel. What is that one we see here? Okay, that diversity in the sense variation, that variation is temperature. My dear students, here in this lesson we will give importance to the temperature. Temperature is one variation or one diversity on the earth surface, right? And have you noticed that in the morning it is cool, when it becomes afternoon, then it turns to warm, again in the night it becomes cool. During the winter we see that it is cool, and the summer we see it is very hot. In the daytime, now it is a morning, early morning, 6 o'clock, it is very cool. By 12 o'clock or 1 o'clock over the head we see it is very hot. By night it becomes again cool, right? We have You have also noticed that it's very hot in some months, that is March, April, May, even to June, right? In some months, uh, there is a very less temperatures, that is cold. This variation of temperature vary from one place to another place on the earth, right? In lower class you have studied polar regions are cold regions, right? And in the African continent, hmm, then Arabian Peninsula, we see that it is hot. So certain regions are cold and some other regions are hot. And these some regions are covered with ice throughout the year, right? And equatorial regions where it is warm throughout the year, and later on we'll see that polar regions which are very cold. So here in this chapter we'll see the temperature differences between places also causes winds and rains. See, my dear students, from one place to another place there is a difference in the temperature. For example, if you look at Africa, Central Africa, there is a very hot it is, right? In Thar Desert, in our India, western part of India, where Rajasthan is there, it's hot region. Northeastern states, it is somewhat less temperatures compared to the western part of India, right? So what I want to say here, there is a difference in the temperature from one place to another place. So the difference in the temperature from one place to another place will cause winds and rains. We know that winds are blowing, right? So these blowing winds are formed due to the temperature differences between two places, and the rains also. And the rain received at a place also what to call decided or determined by the temperature difference between the places. Okay, some places were with less temperature and some other places somewhat hot. So between these two places the temperature difference is there. So for example, at one place it is 40 degrees Celsius. Assume that. Nearby that another place the temperature is some 30. So how much difference is there? 10 degrees centigrade difference is there. So this 10 degree centigrade difference between these two places will rains will cause to what you call winds and rains instead. Then we see that the temperature and rainfall, these are two important factors which help us the our life, plants, animals. All these depend upon heat and water. Right? We are warm-blooded animals, and only some special kinds of trees and plants will grow in what you call hotter regions. We have seen lichens like it very short, which will grow for a short period and die within the short period. Okay, those will study in the polar region. Okay, and some kinds of animals will be different with our region. Polar bear is there, my dear students, that cannot appear in hot and warmer regions, right? We are in warm region, so here polar bear cannot sustain. It sustains in the cold zone, that is the Arctic Circle or Antarctic Circle, right? And in certain regions, we see that due to very cold, there nothing grows. Antarctic is there. It is a barren land covered with ice. So there is no vegetation, right? So here we'll study about the temperature and its differences and throughout world, right? So my dear students, what is the reason for temperature here? The sun is a principal source of energy on the earth's surface, right? We get warmer, and that warmness comes with the sun's energy. Sun is like a powerhouse, understand? Continuously emits or generates the water energy in the form of light and heat, right? When you look at morning, you will see that the light reaches to you, right? That is energy. And certain rays are falling on earth's surface, right? And those rays which fall on the earth's surface will generate heat, right? Due to that, earth becomes warm. So light and heat, these are the two what to call from the sun we are getting, right? That what we call energy. Light is essential for our life, and heat also essential for our life, understand? So this energy which is coming from the sun is continuously emitted by the sun throughout the years after years, day and night. Okay, night in the sense for us night, but for other part of the earth there is no night. Understand? So every moment we see that constantly emitting energy from the sun. That is called solar radiation. Okay, what is solar radiation, my dear students? Solar radiation in the sense the light or the energy emitted by the sun continuously is called solar energy. Okay, this is there. I am picking out here. This one, energy which is constantly emitted by the sun is known as solar radiation. Sun is radiating light into the space, and in that process it reaches to the earth. So light is radiated from the sun. Sun in Greek language is called solar. So it is called solar radiation. When particular object or maybe the body, it emits the energy out, that is called radiation, and that energy produced by sun comes to us in the form of sun rays, right? When we look at the sun, what do we see? Sun rays reaching to us. So the energy comes to us in the form of sun rays. We can see and feel some aspects of the this energy, that is light and heat. Light we can see, right? Heat we can feel, right? We cannot see the heat, but we can feel. So some what to call, the sun's energy to some extent we feel, and we can see also, right? We also receive what you call many other forms of energy. Okay, it is when the sun rays reaches to the earth's surface, in that we see that certain rays, what you call UV rays, ultraviolet rays will come. Ultraviolet rays reaches the surface. Then radio waves, X-rays, these are other forms of energy which comes from the sun, right? And which we can neither feel nor see. Can we see the UV rays? No, right? Similarly, can we see the radio waves? No, right? X-rays? No, right? So that we cannot see them, but we can feel, right? So this energy radiated by the sun is called solar radiation, and it is more or less constant with little variation throughout the year. We may find that in the winter season it is some 16 degrees centigrade or some 18 degrees centigrade. When it comes to summer season, it becomes 40, right? Or 45. Understand? So it is some variation is there in the sun's energy. Okay, what you call the energy received by the earth, what I'm saying. There is no variation in the solar radiation. Okay, solar radiation is constant, right? But in that radiation, whatever earth receives, in that little variation is there. Okay, throughout the year and year after year, we find a little variation, but it finds constant. Okay, then when it is constant, what causes the changes in the temperature of the earth, right? I said that the energy received from the sun is constant, right? But there is a little variation year after year, right? Then throughout the year also we find little variation, right? So the solar radiation received on earth's surface is called insolation. Dear students, don't get confusion. Okay, the concept is different here. Okay, my dear students, solar radiation in the sense energy emitted by the sun, that is solar radiation. What is insolation? Here is earth. So when earth receives that solar energy, it is called insolation. In short, incoming solar radiation to the earth is called insolation, right? So there is the process is same, right? Why do we use different terms here, right? Why can't we use that solar radiation to the in place of insolation, right? See, energy emitted by the sun to the earth is solar radiation. That is constant. In that variation is not there. But the energy which comes from the sun is received by the earth. In that variation is there. So that we call it insolation. That is the difference between solar radiation and insolation. Are you clear? Right. The actual amount of solar energy received on the ground level is only small portion of what reaches the Earth's atmosphere. So what we see that near about 100%. So for example, the solar radiation is 100 percentage. but in that small amount only received, only a small portion of the solar radiation reaches to the earth surface. Instead, the actual amount of solar energy received by the earth is very less. Understand? So, my dear students, what I want to say that the solar energy received on the earth's surface is only small portion. Okay, remaining what reaches the earth's atmosphere, remaining will be trapped by atmosphere. This is because about one third of solar energy reflected back like mirror. When you touch towards the mirror, you will see that a light is reflecting. Right? When you face mirror towards sun, you will see that the sun rays which fall on the mirror is reflected. Similarly, we see that the solar radiation coming to the earth's surface, right? In that little portion only observed by earth, and remaining part of the solar radiation is reflected back instead. Do you think that the total solar energy received by earth? No. If that solar energy, total solar energy, if it is received by earth, it would be fireball. There won't be existence of us instant. Just we are bearing 45, that we can't bear that 45 degree centigrade temperature in the summer, right? But on the sun's surface it will be some thousands, near about some 6,000 degree centigrade temperature on its surface, not at the center, right? So if that all energy comes to earth, you think how it will be? It becomes a smash, or it would be fireball, right? So our earth is not receiving total solar energy. Some part only receiving it. Remaining is reflected back. Understand? So what I want to say here, there is insolation is little, whereas solar radiation is constant, right? There is variation in the insolation, but there is no variation in the solar radiation. That is a point you need to understand here, right? So here, further some portion of energy scattered and absorbed in the higher reaches of the atmosphere. What do we see moving from Earth's surface to higher altitude? Atmosphere is there, right? Atmosphere traps some part of the solar energy. Okay, we see that the harmful UV rays, ultraviolet rays also do not reach the earth's surface, right? Those are trapped and obstructed by the a thin layer, that what we call atmosphere. In other words, in science we'll see that ozone layer, right? The UV rays does not reach the earth's surface, hence it made life possible on the earth. If UV rays uh, reach to the earth's surface, then there would not be existence of the life. Understand? So life is possible because UV rays are not reaching the earth's surface. Understand? By but with our pollution, the ozone layer is depleting, so that there is chances which allows UV rays. We need to protect the ozone layer by avoiding pollution, right? So keep in mind, we'll come to that point again. So some amount of the solar radiation also observed or reflected by the clouds. The clouds are propelling in atmosphere, right? So those clouds also observe some kind of solar energy, right? The smoke which is released into the air, dust which is in the atmosphere, all these dust particles also observe some part of the solar radiation. Okay, and You would have noticed that on cloudy days, huh, it does not get very hot. Have you observed that in the summer when you are moving on a bike with your parent? Hmm? Have you seen that when the cloudy when the clouds takes place, when the clouds cover the sky, you feel, I think you would have seen it's not very hot, right? When the sky is totally covered with clouds, that day it won't be very hot. It means that some part of the solar energy also absorbed by what you call clouds, dust instead. So the total solar energy, that is solar radiation, is not received by earth. In that some part only observed by earth, and in that some part, some is reflected to the atmosphere, and atmosphere absorbs it. In atmosphere several gases are there, right? And clouds are there, dust particles are there, all that absorb some what you call insolation, what solar radiation, they observe some solar radiation, right? Much of the solar radiation is reflected back by the thin blanket, what we call atmosphere, right? Do you understand this? What we discuss here, the temperature is one variation or diversity of the earth. First point. Second point, we have seen that temperature is different from one place to another place, right? Third point, we have discussed temperature variation causes causes winds and rains, right? Then another fifth point, what we studied, huh? It is that solar energy is received by earth is called insolation, right? And the energy emitted by the sun is solar radiation, right? This is the sixth point. Seventh point, what we studied, sun is the source of the energy, right? Energy comes in different forms, right? It comes in the form of light and heat. Some other forms of the energy is what, that UV rays, radio waves, right? X-rays, this. Those are harmful. Those are not allowed by the atmosphere, right? So these are the points we have studied up to now. Next, we see that sun's rays and at the Earth's surface. Have you seen this picture, figure 2.2? Look at this figure 2.2, my dear students. You will understand here what I want to show here. Total, the hello is shown incoming solar energy. That is 100%, right? So sun is emitting, that is called solar radiation. In that, what is observed by earth, that is insolation, right? So how much is reflected in this solar radiation? We see here there is 6% is reflected by the atmosphere, understand? So it means what you call atmosphere reflects 6% after its observation, and the clouds also reflect 20 percentage of the solar energy. Uh, then reflection from the Earth's surface, that is 14, how much it is, 4 percentage. 4 percentage of insolation is reflected by the Earth's surface, right? And atmosphere absorbs 16 percentage. Here it is there, arrow mark, right? Atmosphere observes 16 percentage, clouds observe 3 percentage, and the conduction and rising air. When the air becomes hot nearby Earth's surface, it rises. So rising air also absorbs 7 percentage of the what to call radiation, that is insolation, it is observed, right? And here you see that observed by land and ocean, the earth's surface covered with land and ocean water bodies. So this land and water bodies absorb 51 percentage of the insolation, right? And in that, some is reflected directly to space from the earth, that is 64 percentage, and 6 percentage is reflected from the oceans instead. So this is what I want to say here. Much of the energy is reflected into the space, right? All the things we find in atmosphere will absorb some part, some portion of the temperature, and some is reflected, right? So here we see that even the rays that reach on the ground do not heat the earth's surface uniformly. Suppose the sun rays which reaches to the earth's surface, that does not show equal distribution of temperature throughout the earth. Instead, it means that the temperature absorption depends on the nature of the surface, my dear students. Instead, suppose the surface is covered with tree cover, forest is there the temperature will be low. Where the surface is plain, like a desert, that desert is there we find high temperature, right? So it means the temperature on the earth's surface is not uniform in the sense not equal, not same on every part of the earth. This is because the nature of the earth's surface instead. So this is a that you need to understand here with this picture, right? Insolation, the figure 2.2, look at that what it says. It's a caption is there, insolation and terrestrial radiation. In Greek language, uh, earth is called what you call it, terrestrial, right? So whatever insolation observed by earth, in that some portion is reflected, right? That is called radiation from the earth, my dear students. This is very important point, my dear students. Okay, earth also radiates some kind of energy, that is heat, understand, into the atmosphere, that is called terrestrial radiation. And very important point is that atmosphere is becoming heat and warm by the earth's radiation, not by the solar radiation, right? Are you clear? This will study, this point will help you to understand that why does the temperature decreases going to higher altitude, right? Dear students, when you are at on earth surface, you feel it is warm. When you goes to the some fourth or fifth floor, you feel it cold, right? It means that you are somewhat far from the earth surface, standing at a fourth floor or some fifth or 10th floor, right? It means that you are far from the earth surface, you are near to the somewhat sun. Then what doubt you will get, as we are near to the sun, then there should be high temperature, right? It means that as we are near to sun in the atmosphere, not about beyond atmosphere, in the atmosphere only. That means what I want to say here, our earth is covered, surrounded with atmosphere, no? And this atmosphere traps much of the solar energy and reflects back. Some part of the solar radiation is allowed that directly reaches to the earth's surface. Then earth's surface is heated. Heated earth radiates its excessive heat into the air, and at that time air absorbs that heat, my dear student. So that the lower layers of the atmosphere, the lower layers of the earth uh, surface will be warmer than the upper layers of the earth surface. That means in the atmosphere, at lower layer, temperature is high. Moving to higher layers, the temperature decreases. This point you need to keep in mind. It is very. This is because of terrestrial radiation. If anybody asks you the question that why does the temperature decreases going to higher altitude? Altitude means height. It then you need to think that it is atmosphere is heated by the earth radiation, not by the solar radiation. Are you clear? Okay. So this is we see that, and the insolation received. Now what we have seen here, we have seen that here the points what we discussed here, that earth surface is not heated uniformly. The first point we have seen here in this topic. Now the second point we have seen that the nature of the earth is not same, so the temperature is not uniform, right? And third point we have seen that atmosphere is heated by the terrestrial radiation, not by the solar radiation, right? And these are the points we have seen. Then we have seen the definition of the terrestrial radiation, right? That is energy reflected by the earth into the atmosphere is called terrestrial radiation, right? Then earth's surface. Now coming to another point, you can see from the picture that due to the curvature of the earth's surface, what do you mean by curvature? It is bent. How is the shape of the earth? A spherical shape, right? And earth rotates continuously and also revolves. When it rotates and revolves, it tilts by 23 end of degrees. So by 23 end of degrees when it bends, you will see some curvature that is bent in the Earth's surface. The same amount of the solar energy we see here. My dear students, just 6 minutes is there. And within the 6 minutes, our class is going to complete. Okay. So please keep in mind here. Uh, I may not end that. At the time finishes, it will end. Okay. Just 6 minutes is there, right? Uh, so here the Earth's curvature of the Earth's surface. The same amount of solar energy falls on the smaller area on the equator and on larger area as we move north to or not move north or south of it. You can see from the picture that due to the curvatures of the Earth's surface, the same amount of solar energy falls on a smaller area on the equator and on larger area as we move north or south of it, right? How it is, we'll see here. Thus, it will get warmer on the equator than near the poles. I'll show you how it is. Look at my dear student. This is called curvature nature of the Earth's surface. Instead, curvature of Earth's surface. Due to the curvature nature of the curvature of Earth's surface. Curvature in the sense bent is there, right? That also that what another words in other words what we call it is angle of incidence. Angle of incidence. Look at here. What do you see here, my dear students, in the this figure? Hmm? There is a shorter distance here at equator, right? The sun rays fall directly at equator, covering shorter distance. The solar radiation or insolation here covering a shorter area, whereas it comes to the either north or south, similar, same like this only. Will that in the picture it is not given how it is there here on the north part. In the southern part also will be like that only. It is not given. So on the north part, what you see, larger area is there, right? Because of the curvature of the Earth's surface. It is curvature, my dear student. This is a curvature. So your larger area is there. So to warm this area, it takes much time. So that here will be less temperature compared to the equator. That is the reason we see that the temperature at the equatorial zone is high than the either North Pole or South Pole, right? So if anybody asks that why does the temperature is high at equator and than the North or South Pole, then your answer should be that curvature of its surface, right? That is the first point. Second point is angle of, that only we call here angle of incidence. The sun rays which fall on the earth's surface will bend here. Sun rays are not bending here. What the thing is that earth's surface is not exposed directly to the sun here at north or south pole. So this is called angle of incidence. There is a tilt on earth while its rotation and revolution. So due to that, due to the tilt, angle of incidence is formed here, right? Then only 2 minutes is left, my dear students. Then uh, at equator there is a vertical fall of the sun rays, directly falls over the head. Always at equator we see the sun rays falling overhead, right? How do we see in the morning? It is coming in the east, that is somewhat horizontal to our eyes. But by 1 o'clock, what do you see? You have to see the sun by raising your head. That means over our head, the sun is there. But in equatorial zone, always the sun appears over our head. That means vertical falling of the sun rays is there. Right? These are 2 points. One is angle of incidence, vertical fall of sun rays, and the curvature of the earth surface. Okay, these 3 points are the reason that insolation received on earth is different from one part to another part. Okay, anyway, my dear students, read the textbook and write the definitions. What is a solar radiation? What is a insolation? Right? Then write that in what are the forms of solar energy? These 3 questions. What are the forms of solar energy? Write it. Okay, complete it. Going.